Hello everyone, welcome to our sixth class. In this class we will talk about the guidelines for sitting tasks. Before I start talking about the sitting tasks, I want to complete your MMH part, manual material handling classes by this slide. You may wonder which type of the different method of evaluation of acceptable tasks you should use for your worker, or when you want to evaluate the acceptable load for a worker. So you can see here in this graph, in the y-axis, you have the load. In the x-axis, you have the frequency. And this is a comparison between three methods. One is biomechanical, or NIOSH can be categorized in this category, the Snook tables, and the metabolic assessment by GARG. So from this slide, you can easily understand that the area under curve, or the dashed area, are the areas that are acceptable for, the load is acceptable, the calculated load is acceptable for the worker. When we have very low frequency work, such as one lifting, two liftings, maybe biomechanical evaluation or NIOSH is more reliable, because you can see that the area under curve is in the acceptable zone. When we have a medium frequency between 2 to 8 frequency per minute of lifting, you can see the Snook tables are more reliable and the dashed area is under the curve. But in this low frequency or medium frequency of work, GARG may overestimate the load for the worker. So, however, when the frequency is increasing from 8 to 18 or higher, you can see that the acceptable load is under the curve of the GARG method. And so for high frequency works, it's better that you evaluate the metabolic demand of the job. And based on the metabolic demand of the job, you can decide whether the work is acceptable for your worker or participant or not. Okay, let's talk about the sitting tasks. So some questions may come into mind about the advantage or disadvantage of sitting, and also whether we need to consider the anatomical positioning or anatomical measurements for sitting jobs, and why prolonged sitting may cause injury. What are the advantages of sitting? So, for the jobs that we need a high precision, high visual control, high motor control, we need to have a good stability to do these type of jobs. So sitting can provide a good stability. Also, during sitting, we consume less energy than standing, and the pressure and stress on our lower extremity is lower. And also, the lower hydrostatic pressure can help that we have a better circulation of our lower extremities. So also we can do many tasks in sitting position much better. But as you see, and I'm sure that you have seen this advertisement in many places, that nowadays sitting is considered as a new smoking, that can a habit that can increase the risk of mortality, heart diseases, metabolic syndromes, and even may be somehow associated with poor mental health. Look at this graph and you see that how much more sitting type of work we're doing nowadays. So since 1960 in US till 2010, you can see the percentage of sitting jobs or sedentary type of jobs, and the jobs with light activity is increasing, while the percentage of the jobs that needs moderate activity is dramatically decreasing. So you can see that we spend most of our working time in sedentary or very light type of activities. This slide is related to a study that has been done in Australia, and they measured the activity level of people, adult Australian people, during the day by accelerometer. So you can see that most of the day, about 2/3 of the day, the people are either in sedentary condition or they are doing very light activities. And only 0.2 hours per day they may do moderate to vigorous physical activity. We have good evidence showing that prolonged sitting can increase the risk of mortality, and it is dose dependent. It means that by increasing the duration of sedentary behavior, you will have more chance of having a certain type of disease. Just by standing more than 2 hours per day, the risk of mortality will decrease 10%. And standing 25 to 75% of the time can be associated with decrease in cardiovascular mortality. So you can see just by recommending or encouraging people to stand instead of sitting, you can decrease the risk of mortality and cardiovascular diseases. It's interesting to know that even if a person is doing the recommended physical activity per day, per week, which is 150 minutes per moderate activity per week, but they have a long duration of sitting and sedentary behavior, they still have elevated risk of cardiovascular disease. Besides the health-related problem, I mean, the increasing rate of mortality, cardiovascular disease, metabolic disease that are associated with prolonged sittings, we have so many musculoskeletal problems as well that are associated with sitting activities. Sitting-related injuries are one of the serious occupational health and safety issues. And despite that, with the people during sitting, they don't use their muscles as much as the other workers in other stations, but still they are under the risk of developing different musculoskeletal problems. Some musculoskeletal problems are more common in seated employees, such as neck pain or varicose vein or numbness in the legs. Why we may develop musculoskeletal injuries by sitting while the body is in a relaxed position during sitting? To respond to this question, I need to review a little bit of anatomy and biomechanics. So you know that our spine has 4 parts, 2 mobile parts and 2 immobile parts. The 2 mobile parts are cervical and lumbar, and 2 immobile parts are thoracic and sacral. The sacrum is immobile because of the attachment to the pelvis, and your thoracic part is immobile because of the attachment to the thoracic cage. So when in the erect position, in the normal position, we have a base of the spine in the sacrum and the pelvis area, and the other part to adjust themselves with the pressure and load, compressive pressure that is coming from the body weight. They need to do a little bit of changing of the position in different parts of the spine to harmonize the load all over the spine. These changes can happen in the cervical and in lumbar area mostly, and we have a little bit of changes of the alignment in the thoracic part as well. So we have a lordosis in the cervical part, a small kyphosis in the thoracic part, and again a small lordosis in the lumbar part. This give an S shape to your spinal, to your spine or spinal system that can help to adjust the pressure, the compressive pressures and load all over your spine. The curvatures that I explained were in a standing position when the pelvis is in a neutral position. So when we sit, the pelvis is actually in relaxed sitting. The pelvis actually rotate backward. When we have posterior rotation of pelvis, so we will have changes in the curvature in the lumbar area and the flattening of the lumbar area or the kyphosis of the lumbar area may develop. But we may sit differently and we can tilt our pelvis anteriorly or posteriorly. Based on the job, the sitting position may be different. For example, a worker in an assembly job may sit in erect position and increase the lordosis of the back for doing the job. And so in this position, they have actually the anterior tilt of their pelvis. But a driver usually sit in a relaxed position, so they have a posterior tilt of the pelvis and the increasing of the flattening of the lumbar spine. If you compare the alignment of the spine in standing position in your left side with the upright position in the middle and with the relaxed position in the right side, you can see that when we sit in upright position, the alignment of the spine is much closer to the type of alignment when we are in standing position. Thigh posture can also affect the lumbar curvature. When we flex the hip from 135 degrees to 90 degrees, we may have the flattening of lumbar spine. For the first 60 degrees of hip flexion, we don't need any adjustment in the lumbar spine or in the pelvis area. But when the flexion is over 60 degrees, we have some restriction from the passive elastic tissues, ligaments, capsules, and also the limited flexibility of the hamstring. In this situation, the spine should adjust itself by flattening of the lumbar spine and increasing the developing the posterior tilt of the pelvis. This can give a room for continuing the hip flexion. So you can see that when we have higher flexion in the hip, we actually have higher flattening of our lumbar spine. You can remember this slide from previous class. When we are in standing position, we have a compressive load on our spine, which is somehow attenuated by the intervertebral discs. In the intervertebral discs, we have a homogeneous compressive load on our nucleus pulposus and tensile load on the area around the nucleus pulposus or annular fibrosis. When we are in erect and standing position, the load, the pressure can be distributed, homogeneously. When we bend forward or backward, or when we bend sidewise or twisting, the pressure, the compressive pressure will be higher in one part, and the tensile pressure may be higher in the other side, which is usually in direction opposite to the motion. Considering all these biomechanical issues, some researchers decided to actually measure the pressure inside the intervertebral discs. So they put the transducer inside the disc between L3 and L4 and evaluated the measurement, the pressure inside the disc during standing position and in different sitting positions. If the pressure in standing position is considered 100%, the person who is sitting with a little bit leaning backward will have 105% of pressure inside the disc. But look at this graph, and you can see when the person is leaning forward, the pressure inside the disc will increase to 190%. In the lying position, the compressive load on the disc will decrease to about 24%. This study is much older than the previous study, and again, the researchers measured the pressure inside the intervertebral disc. And you can see that when they compare the intervertebral disc's pressure in a standing position with different sitting position, the one which we have less pressure on our discs is in relaxed sitting with arms supported or in with straight sitting position. You can compare it when you will lean forward, the amount of stress on our discs will dramatically increase. You can see that anatomically or biomechanically, straight sitting is the best type of sitting that you can decrease the amount of load or pressure on your intervertebral discs, while most of the people are sitting in that type of slouch sitting, and so they may apply higher amount of pressure on their intervertebral discs. You may ask the amount of load or the amount of pressure in the intervertebral discs. We're not so high that we can think that they may cause injuries, because it was almost between 500 to 700 Newton, and this amount is almost 1/5 of the action limit that we calculate by NIOSH equation. To respond this question, I should explain the graph in the right side. So you know that the viscoelastic materials have different properties. One of the properties is creep. What that means? It means that when we apply a constant load on a viscoelastic tissue, the deformation, so a force can cause a deformation. A constant load can cause that deformation maintain over time, or the deformation can be permanent. So when we have a constant low pressure on the discs or intervertebral discs, the changes of the disc or the changes of the height of the discs will be permanent over time, or will continue. So that is why that sometimes you can see that the people are the height of people are a little bit longer in the morning compared to the afternoon. The people shorten during the day. Why? Because of this compressive pressure, a constant compressive pressure over the intervertebral disc that shorten the height of the disc. So this is happening when we are in a constant sitting posture. When we are in a prolonged sitting posture, it's the same. The disc creep may happen on our intervertebral discs again, and we will have the deformation of the disc, that this deformation will maintain over time. What may happen? So we may have thinning of the disc, we may have the herniated discs because of the annulus fibrosus reaches to the failure point, and so we have the protrusion of the jelly part of the disc outside, and the pressure on the nerve outside of the spinal cord or in the root of the nerves. We may have bulging discs, degenerative discs, and so you can see that in epidemiological studies you can find the association of the prolonged sitting with the increased risk of different pathology in the back area and low back pain. Besides continuous overloading of our intervertebral discs, we have other conditions that predispose the people in musculoskeletal injuries during prolonged sittings. It's true that our muscles are not so active during sittings. Our back muscles may be active less than 10% of their maximal voluntary contraction. But when we have a prolonged low activation of the low contraction of the muscles, we somehow predispose the muscles to fatigue, and the fatigability of muscles will increase the risk of spasm, the risk of failure, and different type of or strain, and different type of problems in the muscles. In addition, when we have a flex lumbar spine, we have a strain in some passive tissues, and this strain and this pressure on the passive tissues may compromise the blood supply of the discs and nutrition of the discs. When with increasing the sitting pressure, some soft tissues will compress when we sit on those soft tissues for a long period of time, we somehow compromise the capillary blood flow in those areas, and again, they are more predisposed to injury. So you can see in prolonged sitting position, we have a constant loading. We have a predisposition to fatigue because of prolonged low activity of the muscles. We have a compromise in blood supplies of intervertebral discs as well as the muscles that again predispose them to more injuries. So all these components, all these elements together may cause different type of musculoskeletal problems with prolonged sittings. In addition, because of the special position of the body, when the thighs are compressed on the seat, when the limbs are hanging, so we have less blood return to the heart, and so we have more pooling of the blood on the lower extremity, which may cause the edema or sometimes the numbness, and also the development of varicose vein. But what about the standing? We know standing is good for reducing the mortality rate and cardiovascular disease. But in respect of musculoskeletal system, is prolonged standing good for musculoskeletal system? We have evidence showing that more than 30 minutes of constrained standing can increase the risk of low back pain. In the left graph, you can see that in both people with low back pain and in people with no pain, when the amount of standing is in 45 minutes, they have a higher perception of pain and discomfort in their back area. It's true that prolonged sitting and prolonged constrained standing both can have bad effects on our musculoskeletal system, especially on our back area. But evidence tells us that sitting is worse for spine health than standing. And evidence tells us that if we want to have a good sitting posture, we should somehow preserve the lordotic curve of our spine, similar to the curve that we have in standing position during our sitting position. And also, science tells us that during the sitting position, we should involve frequent postural adjustment to have a better and healthy spine. Because when you move the spine, you can somehow prevent that creep recovery, creep occurrence that I talked about before. And also we can improve the disc nutrition. We can fluctuate the pressure in different parts of the disc, so somehow prevent the concentration of the stress in just one point. And we can also involve different muscles in the body to be active and contribute in the posture. So the muscle fatigue will decrease and we will have better blood flow to the muscles. Now that I reviewed the biomechanical backgrounds of different problems related to prolonged sitting, I want to talk a little bit about the preventive measurements that we can use in our workplaces. So it may be a good idea that we use treadmills in our work stations, but it's not practical and they are expensive as well. So let's see which other options we may have. Three components are important in this respect. One is job design, the other one is workplace design, and also the education and training of the people or workforce. The main point in job design is to reduce the amount of the time the person just sit, and also give the person enough breaking time, especially every 40-50 minutes, to stand, walk, and also sometimes to do stretching exercises. One of the good options is to combine the sitting and standing workstations. If you look at some of the workstations, they apply this strategy. For example, at the University of Waterloo, some of the workstations are designed for the workers that they or the employees that they can do some part of their jobs in sitting posture, some part of their jobs in standing postures. It's a wise workstation design, especially for the jobs that the people need to sit for a long period of time. How much standing is appropriate, or how much changes in sitting and standing is appropriate? There are different suggestions from 1 to 3, which means 1 hour of sitting, 3 hours of standing, to 3 to 1, 3 hours of sitting, 1 hour standing. So you can find different recommendations in the literature. I chose this one, which has been written by Dr. Callahan and his colleagues at the University of Waterloo. I uploaded this article on your Blackboard, and their suggestion is a ratio of 1 to 1, which means that for an 8-hour workday, it's better that the workers sit for 4 hours and 4 hours of walking or other type of standing activities. Interestingly, in some workplaces, we have activity breaks instead of rest breaks. So the people can be away from their desk, walking, do some activities, even they can do some type of exercises, such as stretching exercises or even strengthening exercises in the workplaces. In workplace design, again, we should consider 3 elements: tasks, workstation, and chair. Let me first define 2 terminologies. One is good sitting. A good sitting position is when an employee can have enough space to change their body position frequently and naturally within a normal and acceptable range of motion without being restricted by workstation or by job design. While by balanced body position, I mean a body position that can somehow handle the pressure over different musculoskeletal systems such as muscles, tendons, ligaments, etc. And in balanced body position, your feet, thighs, spine, shoulders, elbow, etc., they should be in a special position or posture that can somehow deal with different type of stresses. I don't want to go through all this part by part of the body. You can read the detailed body posture by yourself. I may ask you some of these postures in your next quiz. But please remember this 8 components of a balanced or a neutral body position during sitting. 1, the head and neck should be balanced and in line with the torso. Shoulders should be relaxed, not in a round position. Elbows are better to be close to the body. In some work, it's better that they be supported, such as the computer work. And they should be flexed between 90 to 120 degrees. Wrist should be aligned with the forearm without having the wrist flexion or extension during work, and they should be parallel to the floor. It's better that we have a low back support with sitting in erect or straight posture, and sometimes it's better to lean a little bit back slightly. Thighs and hips should be supported with a well-padded seat and generally parallel to the floor. Knees are should be in the same height as the hips, with the feet slightly forward, and the feet should be fully supported by floor or by footrest. So one of the basic things for a workstation is that the person can be remained in a balanced position or neutral posture during the work. A good workstation should allow the worker to sit or stand with good alignment of the spine, be able to move freely their spine, and also to adjust the workstation based on their needs. The type of tasks is also important. Some tasks may apply more pressure in a special part of the body. For example, office workers or the type of work that needs visual tasks place a lot of tension on the neck and trunk areas. That is why that many of the office workers may suffer from neck pain, especially when they should maintain a required vision for a long period of time, and especially and more specifically when they need to bend their neck. They do the job in flex the neck, or when the height of the monitor or their laptop is not properly adjusted. You know that the cervical spines are under compressive pressures applied by the weight of the head. The head has 8% of the total body weight, especially when the neck is not in an erect position with the body. This load will be much higher, and the load is not properly harmonized in different part of the intervertebral disc and the body of the vertebrae. Therefore, based on the current knowledge, we know that an office worker should sit erect, the head should be in line with the spine, the monitor should be an arm length away, and the height of the monitor should be adjusted by the person's eyes. For some jobs, the workers need to do light manipulating tasks. For those jobs, maybe a wrist and arm support can help to prevent excessive or continuous wrist flexion or extension. And you know that these postures may predispose the worker to carpal tunnel syndrome. For heavier tasks, when the worker needs to have better control over the tasks, it's better that we arrange the work surface below the elbows height, so the person can have better force application for the job that they are doing. In any workstation, it's important that when the person is applying the force, the spine be in vertically aligned position. And also, it's important that you design the workstation in a way that the workers do not to lift or transfer heavy loads horizontally. You know, when they need to transfer the load in horizontal plane, they need to have spine torsion, or they need to turn in different sides. And as you know, and we talked about it before, spine torsion can predispose the spine to more injuries. The reaching area is also important. So the materials should be designed in or arranged in the at elbow height or slightly below the elbow height, as I told you before. And also it's better to avoid heavy hand tools, and avoiding the task that shoulder and arms should be excessively high. So it's better to keep the things below 50 centimeters above the surface. And also the task that needs that required excessive reach. They are all important to be considered in workstation. Based on the reachability of the materials in a workstation, we have a primary zone, a secondary, and a tertiary zone. So in primary zone, which is the immediate reach, it's for the most important or frequent things that the person should use. In the secondary zone, which in the arms reach, the lower importance materials should be installed. In the tertiary zone, which are farthest, and the person needs to bend forward to reach the materials in that zone, we usually should put the stuff that the person rarely may use them. Some sitting jobs include foot tasks. For example, the person should work with a pedal. So it should be considered that for this job we designed the workplace in a way to prevent the hip twisting, providing a good support for both legs and help the person to use both legs, not just working with one leg. Different policies have been developed to reduce the amount of musculoskeletal disorders and other health-related problems which may cause by prolonged sitting. For example, in Canadian Standard Association (CSA) standard, you can see that they encourage or they recommend the alternating sitting and standing and a variation of sitting and standing posture to avoid the negative effects of sitting or standing in one posture for a long period of time. The other important issue for sitting jobs is the chair. And it's important that the chair be adjustable and also be appropriate for the type of tasks that the people usually do during that job. Most of the chair designs are based on anthropometric measurements. You know, we have two types of anthropometric measurements. One is static, the other one is dynamic. In the static measurements, we describe different dimensions, distances, for example, the distance between the head to the buttock, the distances between two shoulders, the distances between the buttock to the knee, and etc. In the following picture, you can see some of these definitions. So all these measurements are based on a defined and unmoving position. If you want to have better understanding of the definitions of anthropometric dimensions in sitting position, you can see this table, and if you want, you can use this table for anthropometric measurements during sitting as well. Taking static anthropometric measurements is easy, and you can measure different dimensions and adjust the workstation workplaces based on the 95% or 90% of population that they have the average dimensions, the average measurements in 90 or 95% of population. But the reality is that people don't work based on the predetermined specific positions. They work in different positions, they have different approaches. So for designing a workplace, it's important that you consider both the anthropometric static measurements and dynamic measurements. By dynamic, I mean the distances for the workstation that I showed you before, based on the reachability and based on the design of the things around the person and how they use the stuff during the specific work. So both of those type of measurements can be taken into consideration. Nowadays, you can find a lot of advertisement about the ergonomic chairs, and so it's just by the title or label of ergonomic, it doesn't mean that the chair is good for a person. So the chair should be suitable for worker size, as well as the particular workstation that they work, and also the type of tasks that they supposed to do. You may use some of these anthropometrical measurements to, find a good chair. For example, the seat height of the chair is recommended to be a quarter of the body height. So it's good to measure the body height first of the workers, and based on their body height, you select the chair. As I told you before, just by one measurement or a certain measurements, you cannot say that whether this chair is good enough. So you need to evaluate different features to be able to choose a good chair for the worker. One is adjustability. So it's important that you see first whether the seat height is adjustable or not, and if yes, what is the range of the height that whether they are appropriate for for your worker based on their anthropometric measurements. I mean the height or the length of the thigh and etc. The other one is the backrest. Again, check whether the backrest is adjustable, especially for vertical and forward and backward direction, and also whether there is a firm lumbar support. Seat depth is also important, especially for very tall or very short users. You know, for example, if we have a lot of pressure on the popliteal area of the knee, so we may have some kind of compromising of a neural system in that area or a blood supply in that area, and the worker may have numbness or increase the level of fatigue. And also stabilities. For some work, we need high stability. For some work, we need more, moving a chair. So it's important that you see whether the stability of chair is good enough, especially for work that we need high stability. It is suggested that 5-point base is better, but it's based on the availability. So you should always ask yourself whether the selected chair will help person to do their job better. For example, maybe for a person, for an office worker who is working with computer all the day, the arm rest with adjustable height is a good option. And also you should check whether the chair can somehow make the job difficult for your worker. For example, if somebody needs to do the job in a stable chair, so if they are using a chair with wheels, so the job may be performed with more difficulty. Okay, finally, we'll talk about different strategy and different preventive methods in workplaces. But I should emphasize that education is one of the most preventive strategies everywhere, including the workplaces. So you can educate your people if you work as an ergonomist, for example, whether their sitting habit is good or bad. If it is bad, how they can adopt a new sitting habit, how this sitting habit can affect their spinal health, how they can reduce the fatigue, how they can reduce the time of prolonged sitting, and etc. If you are looking for a good resource, I think this website can help you. Many of the slides that I prepared for you today is from this CCOHS website, and you can use the materials as well if you are involved in educational activities in future in any workplaces. To sum up, a good job design should allow the worker to have a variety of balanced positions, encourage them to alternate the positions frequently, encourage them to avoid static positions for a long period of time, or have a good alignment of the head and spine during especially visual tasks. Also, a good job position should help the workers to avoid excessive range of motion by providing a good reachability of the materials that they need and preventing them to lift and transfer the loads in sitting positions. And again, the chair choice should be appropriate based on the anthropometric measurements and also based on the type of job that the people are doing. And finally, again, I emphasize that education, education, and education. Who knows, maybe in future we can design the workstations like this for people, and so people may have less musculoskeletal problems. But anyway, thank you very much for your attention. I will upload a quiz for you on Friday afternoon. The quiz is mostly related to the sitting PowerPoints, the slides that I provided for you today. You just need to look at the slides and you will be fine to respond to questions. I wish you very happy Thanksgivings and I hope you enjoy your study week.